Part 3 of graphing trig functions. If you don't recognize this rectangle, you can go back to the first part of graphing trig functions where I quickly talk through that. But we're just going to continue on as if you've seen the others. So here, we're going to do number 9, and we're going to look at phase shift. And phase shift, there is something added to theta here. So our period is left 3 pi over 2, or we realize going left is negative, so negative 3 pi over 2 or negative 3 halves pi, either way. So that's going to be a change for us. We haven't had one like that yet in those first 2 videos. Going to the other things, the period. The period would be if there's something multiplied out here, there is just an understood 1, so the normal period of sine is 2 pi divided by that 1, which is obviously still 2 pi. The amplitude. Amplitude is what's multiplied outside here, also an understood 1, so our amplitude is 1. And there is nothing added out here, so the vertical shift is 0. We are going to go ahead and draw our axes. I gave a little more room here, so I'm going to come down, try to draw a straight axis here. I make it longer here just so we have some room to work with. I am not going to draw the y-axis in yet. I'll put that in later. So our starting point, it's always been 0 and now it's changing. So our starting point is negative 3 pi over 2. So that's a negative, so I'm going to put that right here, negative 3 pi over 2. And then, as I've written so many times before, we're going to add a period, out of room here, a period, which in this case is 2 pi, to get the end point. All right, so before we just took 0 and added 2, which was easy, but we have negative 3 pi over 2 plus 2 pi. Some of you will be able to do this quickly. Some of you might be like, well, I'm going to get a common denominator. If you can do it quickly, great. I'm going to show the other way just in case. So we need a common denominator. So we have to multiply this by 2 over 2. And so this is negative 3 pi over 2 plus 4 pi over 2 is positive pi over 2, 1 pi over 2. All right, 1 pi over 2 or pi over 2. So our end point, I'm just kind of picking a random spot here, and I'm saying that's our end point. Maybe I should have put this in blue so pi over 2. All right, then we split that into 4 equal parts. So there's our middle, and then split those in half. Now, it is typical to label what these values are. And so this, the one I'm highlighting here, is halfway between negative 3 pi over 2 and pi over 2. So to get the middle, you can just find the average. And you can think through this different ways. So one way is to find the average of it. So how do you find the average? Well, you add 2 things together. So negative 3 pi over 2 plus pi over 2. So you add them together and then divide by 2. So negative 3 pi over 2 plus pi over 2 is negative 2 pi over 2 divided by 2, which actually is negative pi over 2. So that's negative pi over 2. And then, and again, there's different ways to do this. Sometimes one way is more helpful than another. But this point right here, notice What's halfway between negative pi over 2 and pi over 2? Well, that is 0. So that actually is 0, which is our y-axis. So we don't always start, or we don't, when there's a phase shift, we don't draw a y-axis to start with. But there it is. Sometimes the y-axis won't even be on a special, or one of those 4 points, but it is in this case. All right, so that part takes some work, but we have our starting point, we have our ending point. We split it into 4 equal parts, and we can do our amplitude. Our amplitude is 1, so 1 and negative 1. Some guidelines. Now we do not have a vertical shift, so we are graphing sine. So sine starts on 0, goes up to 1, down to 0, down to negative 1, back up to 0. That's our first full cycle. And then we can continue that pattern. And there's a little bit more of that. All right, so there's our graph. I want to just go off a little bit and talk about something here. The spacing of our 4 points. So like this was our first cycle. Let's see if we can just, this was our first cycle right here. And dividing that into 4 equal parts. Another way to think about that is your period is 2 pi. 2 pi divided into 4 equal parts. 2 pi divided into 4 equal parts is just half pi. So there's a half pi between each of these points. And then that actually just keeps continuing. Half pi, you can keep adding half, 1/2 pi, and that will get you to the next point. So that's another way to think through what those values are. All right, number 10. Number 10, so we have y equals cosine of theta minus pi over 6. This minus pi over 6, we're subtracting. So that's our c, which is going to have to do with our phase shift. So this is going to be right pi over 6. Our period is an understood, there's an understood 1 there. So it's 2 pi over 1, which is 2 pi. Amplitude is an understood 1. There's no vertical shift. And so we can put in our axes here. We are not going to put in our y-axis yet. We're going to put our starting point. Pi over 6 is pretty small, so I'll just start about right here. We'll call that pi over 6. How do we find our ending point? Well, our starting point is pi over 6. And we are going to add the period, which in this case is 2 pi, to get our end point. And so we have pi over 6 plus 2 pi. Well, common denominator, you can multiply this by 6 over 6. And that end, so you'll have pi over 6 plus 12 pi over 6 is 13 pi over 6. That's our end point. So we'll just put that out here somewhere, 13 pi over 6. Some of you are thinking I made that harder than necessary. Probably. So we could have done pi over 6 plus 2 pi is 2 and 1/6. But there we have, there's 13 pi over 6. We split that into fourths. All right, well, what is halfway between 1 pi over 6 and 13 pi over 6. So what's halfway between 1 and 13? Again, we could find the average. 1 plus 13 divided by 2 is 14 over 2. So 7. So this is 7 pi over 6. And that's good enough for now. We could keep going. What's halfway between 1 and 7? So halfway between 1 and 7, 1 plus 7 is 8 divided by 2. So this would be 4 pi over 6, which of course, oh, it looks awful. That says 4 pi over 6. That could reduce. Anyway, that means our y-axis, so think about this, our y-axis is somewhere over here. It's pretty close to pi over 6, so I'll put that y-axis in there. And we are graphing cosine. Well, I didn't mention our amplitude was 1, so here's 1, here's -1. Cosine starts up. Now, we're not starting on the y-axis, we're starting at our starting point here, pi over 6, so we're starting up at 1. So we've been doing this in black. 1, then down to 0, down to -1, back up to 0, back up to 1, and then that pattern continues. It also continues backward. Now, if you wanted to find this point, we could do that. There's a few different ways. One way is, this is just another quarter of our period. So anyway, you could take the pi over 6 and subtract half pi. But, all right. So these, you just keep doing the same thing. We have our phase shift. This is going to be right pi, 7 pi over 4. Our period is just 2 pi over and understood 1, which is obviously still just 2 pi. Amplitude is 1. And there is no vertical shift. Let's come way down here. We are going to start at 7 pi over 4. 7 pi over 4. We'll just put that right here. 7 pi over 4. We're going to add the period. Of 2 pi to get the ending point. Uh-oh, I'm getting sloppier here. To get the end point. And so we have 7/4 pi plus 2 pi so plus our period. We'll go ahead and multiply that by 4. So this is 7/4 pi plus 8/4 pi gives us 15/4. So the end point is going to be 15/4. We will split that into 4 equal parts. What's halfway between 7 and 15? So I've been doing this one way. Let me just, and I taught another way. 2 pi, the period is 2 pi. So from the starting point to the ending point, this length here is going to be 2 pi. We're splitting 2 pi into 4 equal parts, which is 1/2 pi. And for our sake, we might want to think of this as 2/4. We might want to just think of 2/4 because the denominators are fourths. So we can take 7/4 pi plus 2/4, so this is 9/4, plus another 2/4, which is 11/4, plus another 2/4, which is 13/4, plus another 2/4 is the 15/4 that we have there. If we wanted to go backward, we could subtract 2/4, so this would be 5 pi over 4. And the reason I'm doing this is so we have a rough idea of where our, I should put all these little bumps here. So that's 3 pi over 4. 1 pi over 4. Negative pi over 4. And now we actually know our y-axis is halfway between those two. But back to graphing. Back to graphing. We have an amplitude of 1. So we'll go up to 1, down to -1. But we're going to come over here at our starting point. We are graphing cosine again. So cosine starts up. So on our starting point on this green at 7 pi over 4, we're going to start up. We're going to go down to 0. I'm going to put the guidelines in here. So we started at 1, down to 0, down to -1, back up to 0, back up to 1. That pattern would continue. And then we can continue the pattern to the left of the starting point. Oh, this was not part of it. That was just the y-axis. That wasn't one of our points, so we can continue that graph. And there is that. We'll go ahead and stop there for now.